Today I want to show you how to take existing microservices like the Smarta Byar Smart Village application and integrate it with Red Hat OpenShift data science to do some powerful computation at runtime with AI ML. Let me show you what I mean. So this is on the left, the Smart Village application, and we generate simulation reports of traffic at intersections. So I'm going to log in to Red Hat Single Sign-On, get access to the dashboard for simulation reports. And this is my simulation report, and there's many values that I can adjust in here that you can see. And I can run a report very easily like this. I click Run Report, but nothing's happened. Let me show you why. So here is the Smart Village application deployed in OpenShift, and there's many components to this, from AMQ Broker to AMQ Streams, MongoDB, Postgres, Apache Solr, Apache Zookeeper, and FiWare IoT Smart Data Device components. But what we're going to focus on today is the Smart Village application right here and the Red Hat OpenShift Data Science project, which is this one. So this is Red Hat OpenShift Data Science on the right. And if I take a look at my deployments, it's in workloads, deployment configs. This one is scaled down. This is the one that's supposed to receive messages, but we're going to edit this code live in Red Hat OpenShift Data Science. So what I do is here in my project, I open a terminal and I can clone the application. It's open source and it's at github.com/computate-org/TLC, which stands for Traffic Light Controller. So I will grab this clone URL and git clone the repo. Now I go into the repo and there's a script. Let me check out the branch. Git checkout computate-API. And in here we have run TLC. So if I run this, then it starts a listener that goes and runs that simulation report. So over here, we'll see the simulation disappear because it's starting with new content and it's populating the data. It says it's running. It updates this graph as it works. So it's sending back Kafka messages back to the Smart Village application. And then the Smart Village application updates the data that comes back from Red Hat OpenShift Data Science and uses WebSockets to refresh the user interface here. So it's gone through 4 iterations. And now it's gone through 5. We set it to 6 iterations. And now it's completed. Now you can easily update this code. There's currently a bug where sometimes this report status does not get marked as completed and stays as running. So I want to edit the code to fix that. So I go and open the run. Let's see, it's in app.py, and I look for where it sends the data. Complete. right here. So I'm going to copy this line because this is useful to me. I'm going to copy that, and I'm going to delete that line here because I want to move it. So I move it out, and I edit main pedestrian.py and look for where it sends the message. So here, I'm going to say if iter num equals total iter num minus 1, that's where I'm going to update the Zookeeper cluster manager that the simulation report is completed. And then in here, I want to set the report status to be something more dynamic. So we set it to running if iter num less than total iter num minus 1, else completed. And then I think we're good. So I'll save and close that. And because this is running in the same OpenShift project and namespace, then I'm just editing my code live in the OpenShift cluster. Now I can run the report again. And it got the update. Now it's set to running status again, and it's running the updates. So side by side, you can develop at runtime your applications through Red Hat OpenShift Data Science and do AI/ML processing in containers in a web interface. It's very powerful. So I hope this was helpful. I hope you learned something today. We're almost done running this simulation. It just needs to get through 6 iterations. So that's it. Thanks for watching.